Hello and welcome to the practice problems for our mesh analysis. The mesh analysis, remember, is always written in terms of the currents, and we'll be solving for the currents. So we want to solve for current 1 and current 2. Remember that as we go around, the overarching rule that we're applying is KVL, Kirchhoff's voltage law, and that says that the sum of the voltage drops has to equal 0. So each of the terms that we have in our equations will be voltages, and if we sum the voltages, then we will get 0 according to Kirchhoff's voltage law. When we go around each of these meshes, then, we'll have a term for each of the different elements. So for the equation for mesh 1, we'll have 3 different terms, and it'll equal 0. And then over here, we'll have 3 different terms, 1, 2, 3. For mesh 2, we'll have 3 terms equals 0. Now, some of these will be a scalar because we have voltage sources in here. But when we are writing these, remember to keep in mind that it is the voltage that we are summing up. But we will have then resistors and currents in here. Each of the terms will represent a voltage, but it will have a current in the equation. It will be a resistance times a current, which gives us a voltage. So for this, we have 2 meshes, and then each of the meshes will give rise to an equation, so we'll have 2 equations. And in this case, each of the equations will have 3 terms. Let's start over at the 42 voltage source. I'm going to start here, and then our convention is that we always go around clockwise. Clockwise is what the current is shown here. That's just a convention. We could go the other way, but we'll follow the same procedure for each of these so that we get used to a pattern. Now we move through, and we are going through a 42 volt voltage source. And when we go through, we see that we're actually rising here. We're going from a negative to a positive. We're summing the drops in this case, and so we're going to get a minus 42. One way to think about that is, well, we're summing drops, and so this is a 42 volt rise, so we want to sum the drops and put a minus sign. Or the shortcut is when we drive around this circle, since we hit a minus sign, we put in a minus. So you can think about it in either way. So we get minus 42 for mesh 1, and then we're going to hit the 6 ohm. So this is 6 ohms, and it's times current 1. So this is going to be 6I1. And then we have to go through the 3 ohm resistor. So with this 3 ohm resistor, it is not just I1, because I1 comes in this way, I2 comes out this way. We need to find the vertical current, and this vertical current that's going through from top to bottom through resistor I3, that's going to be I1 minus I2. I1 minus I2 in that case, and that's going to be going down. And since we're following that clockwise direction, we're going to get 3 times I1 minus I2. Remember then, this is all equal to 0. Next, we go around the loop number 2, the mesh number 2. And we'll start right here, and we'll move around. So then we're going to have 4 times I2. And then we go to the next element, we get a negative. We hit this negative, so we get a minus 10 in this case. And then plus, we've got that 3 again. We're going to be going through this, but we want to know what the current is going up. Well, that's just going to be the opposite of I1 minus I2. If we take this, we've got I2 and we got I1 coming down, so this is going to be I2 minus I1 is what's going up, and we want up because we're going clockwise, so it's going to be 3 times I2 minus I1 equals 0. Okay? Then as a sanity check, we'll say that, okay, each of the I1 terms better be positive in here. It is. And then down here, each of the I2 terms needs to be positive. They are. And notice then that we've got the symmetry because we shared this mesh. It's going to show up in equation 1 as I1 minus I2. You're going to see the same form, the same factor, but for the I2 equation for mesh number 2, you'll see I2 minus I1. All right? And for the problem, it says just write the mesh equations, and we've done the job for that. Okay. Now, here, we're just asked to write the mesh current equations. We don't have to solve anything. And so we get used to running around the two loops. Now we have two meshes here, two meshes, so we're going to have two equations. And then in mesh 1 equation, we're going to have 3 terms. And then in mesh 2 equations, we're going to have 4 terms. 2 equations, a 3-termer and a 4-termer in each one of those. Now here, we don't have the currents labeled as we did in example number 1, so we get to choose. But so that we're all on the same page, the tendency is we usually start from left, go to right, and then increase the index each time. Now the common notation that they use here is just like 3/4 of a circle, and they don't have anything for the orientation. But honestly, it's important to realize that I1, we're going to label this I1, but I1 is only the current that goes around the outside portion. So we usually draw it sloppily by just putting a label in there like that. But if we want to stress it, I1 is the current that's flowing around the outside loop here. So the current going down through 3 is not I1. Likewise, I2 is only the current that's going around this outside unshared portion. So make sure to keep that in your mind. The way they've drawn it up here makes it look like, oh, I1 is going through that 3 ohm resistor. No, I1 is only defined as the outside route for here too. Okay, we're going to have that difference in the middle term for the 3 ohm resistor when we do it. Well, we only have to write the equations. There's going to be 2 equations. There's going to be 3 terms and 4 terms in here. Let's go. We'll start here down at the bottom corner. And so we've got 2 times I1. And we've got minus 5. Because we hit the minus sign, we're going to traverse the entire mesh clockwise. So we hit a minus sign, so we get a minus 5. And then when we hit the 3 ohm resistor, that 3 ohm resistor is going to be I1 minus I2. All of that is equal to 0. And, okay, I1s, they're all positive, and that's good. And then the negative term comes from the fact that we're in mesh 1, not in mesh 2. All right, the next one. Let's start right here, and we'll move around. And so we get the 6 times I2, and then we hit the 10-volt source, but we hit the plus sign, so this is going to be a 10-volt drop. Remember, we're summing the drops, and we got a 10-volt drop here because we start up and we go down, so that's going to be a plus 10 in the equation. Then 12 ohms times I2. And then finally we get the shared current, that's going to be plus 3. And since this is shared, we're going to get I2 minus I1, because we're going to, when we get there, we're walking up the diagram, we're walking in this direction. So then this current here is I2 minus I1. And that's where this gets rise to. Notice we have the symmetry. All of this is equal to 0. We could then do algebraic manipulation and then solve, but the question doesn't ask. The question says just write the equations. So this is the same sort of template that we're going to follow for each of them. And as we move to then example 3, we say solve for the 3 mesh currents in below. So we've got 3 meshes. We're going to have 3 currents. Here they didn't label it again, but normally what people do is they just, like this, they just write 1, 2, 3 like that. But since you're just getting started, that's the convention that you'll see. But I wanted to really stress the fact that the currents that we're solving for are only the unshared portion. So we're going to call this I1. That's the outside part of the loop. And then this is going to be I2, and that's the current that's going here. It's not readily apparent, but this is also I2. That's coming because if the current comes into this node, the current has to go back out of that node. So the current that's flowing through this leg is I2 and here, but we're going to get shared portions through these two. So that's I2. And finally, we've got I3. And I3 is only this current around the outside leg. So since we have three different meshes, we're going to have three different equations. The equation for mesh 1 will have three different terms. The equation for mesh 2 will have three terms. And the equation for mesh 3 will have three terms. All right, let's get started. We have to do the full shebang. We have to solve for the mesh currents here. And so for this, we'll get started with the first started for the first equation here. We're going to have minus 2. We're going to start here. We hit a minus 2. Then we get plus 12.5 I1 from this. And now we've got a shared loop. This is going to be I1 minus I2. So I1 comes down, I2 comes back up, and the net current is I1 minus I2. So that's going to be through the 10 ohm resistor, and that's going to be I1 minus I2, and that's all equal to 0. For mesh number 2, let's start right here, and we'll go through and we'll have 11. I'm going to leave a little space so that we can simplify these. 11.25 I2. Now we have to hit the 50. But that's a shared one, and that's shared between I3 and I2. So we're going to get I2 minus I3 times 50. And we still have the 10 to worry about. And so the 10 ohm, that's going to be I2, but it's shared with loop or mesh number 1. All of that is equal to 0. Okay, and then finally we have the last. We're going to start up here. We'll start up here and move around. So we've got the 20 times I3 plus the 10 times I3 plus the 50. The 50, now the 50 is shared, and it's I3 minus I2, and that's equal to 0. Okay, so we've got our equations. Hopefully they're written correctly. Now we have to do algebraic manipulation. Remember, at the end, we're going to want it in block linear form so we can easily enter it into a calculator or other solving device. So first of all, when we look at this equation, we're going to banish the 2 over to the other side so that we get rid of that. And then we'll look at all the I1 terms. They should be positive. They are. So we get 22.5 times I1. And then we look at all the I2 terms. We just have the 1, which is a negative 10. And then we leave some space. We don't have any I3 here. So 22.5 I1 minus 10 I2 equals 2. For the next one, well, do we have any constants? We don't have any constants, so that's going to end up staying and equals 0. Then we will look for all the I1s. Okay, here's the I1. We're going to get a negative 10 I1 in this case. Now we've got to look for all the I2s. Now all of the I2s should be positive if we have resistors which have a positive variable. So we've got 11.25 plus 50 plus 10. So that's going to be 71.25 I2. And then we look for all the I3s, we scan, and then we get a minus 50 I3. Finally, we go down here and we look, we only have I3s and I2s. We don't have any I1s, so we'll have a little blank there. And then let's look at the I2s. That's going to be minus 50 I2. And then all the I3s for loop 3, mesh 3, should be positive. So we get 20 plus 10 is 30, plus 50 is 80. So we get 80 I3. And then that's going to be equal, there's no constants here, so that'll be equal to 0. All right, next we put it into block linear form, and we'll gain some insight into the system. When we do that, we get 22.5, negative 10, 0, negative 10, 71.25, and minus 50. We get 0, minus 50, and 80. Our variables, I1, I2, I3, and that's going to be equal to 2, 0, 0. And this is our form. And so when we look at this, do we have symmetry? Oh yeah, we have symmetry on the off-diagonal elements. The off-diagonal elements are all symmetric. And then along our diagonal itself, they will all be positive and most of the time unique. So they're all positive, and then that gives us some credit, that gives us some assurance that we've done our job right. Now that's not always the case, but that's a good sign. All right, plug this into our equation solver. You can do it in any of number of different ways, and you'll get I1 is equal to 100 milliamps. I2 is equal to 25 milliamps, and I3 is equal to 15.6 milliamps. Okay, so that was a long slog, but as long as we're careful with the algebra and careful when we write down the equations, we should be good. Finally, we've got another one, and it says write the equations and then also reduce it. So we don't have to solve it in this case, according to what the question asks for. Let's go ahead and write the equations and then simplify the equations. So we already have the labels for us about which ones to use in what place. In this case, though, remember, even though this little label draws through the vertical point, it is not the case that I1 flows through either of these branches. This one's going to be I1 minus I2. This current here is going to be I1 minus I3. Okay, so I1, it's only around the outside edge. I2, it's only around this outside corner. I3 is only through the 7 ohm resistor. Let's begin. For this mesh number 1, mesh number 1, we're going to start in the lower right-hand corner. We get a minus 2, and then we get a plus 1. That's going to be shared, so that's going to be I1 minus I2. Then we're going to get a minus 3, because as we come through here, we've already done resistor 1 ohm, and we hit a minus 3 here, so we get a minus 3, and then we're going to get then through this, we're sharing between 1 and 3. We're in mesh 1, so the current 1 always comes first, and then all that is equal to 0. Okay, for number 2, mesh number 2, let's start up here and move our way through. We're going to start up here, and so we're going to get 6I2, and then we go through and we get plus 9. Now that 9 ohm resistor is I2 minus I3. It's always the mesh index of interest minus the shared mesh. Then we go here, and we finally have to take care of the 1, and that's going to be I2 minus I1 equals 0. Okay. And then finally, for I3, we're going to have 4 terms in that. Let's start I3 going this way. That's our starting point, is all I'm denoting there. So we're going to get 7 times I3. 7 times I3. And then we're going to get plus 5 times I3 minus I1. That's this. So we get I3 minus I1. We hit the positive node of this, so we get a plus 3. And then we've got to go through the 9. And we're working on 3, so the I3 always comes first. And then what is the 9 shared with? I2. Good, and that's going to equal 0. Next is to simplify each of these. Hopefully we've written them correct, but we're going to simplify them and put them into block linear form. And when we get that, we can do some checks to make sure that we have our symmetry conditions and positive diagonal element conditions as well. So when we move this through here, we get 6i1 minus I2 minus 5i3 equals 5. And down here we get negative I1 plus 16i2 minus 9i3 equals 0. And down here we get minus 5i1 minus 9i2 plus 21i3 equals negative 3. So when we put this into the block linear form, we have 6, negative 1, negative 5, negative 1, 16, negative 9, negative 5, negative 9, 21. Let's check it out. Do we have off-diagonal symmetry? We do. Negative 5, negative 5, negative 1. We've got the off-diagonal symmetry. That's good news. And we also have positive diagonal elements. And as we were saying, minus 5 I1. So this is all we were asked to do. But in case you wanted to go ahead and solve this, or in case you were super curious, we get 989 milliamps. I2 is equal to 150 milliamps. And I3 is going to be equal to 157 milliamps, although this was all we were asked for in the equation. All right, so that is the last of the practice problems for mesh analysis.